Hello and welcome to today's video by the AM Academy. Today, I have something pretty special because the boys over at Shining3D were nice enough to send me their Inspec, a 3D scanner, at least for a couple days so I can try it out. This is part of their metrology line, meaning it is designed for very high accuracy scans, for example, in quality control of a company. It fits in together with some of its other scanners, such as the FreeScan UE7 or 11, which are handheld laser scanners. Now these ones, because they're handheld, are designed for big objects. So you, have an engine of a car and you can walk around it scanning it, or the entire front of a car. But this one right here, this one is designed for small parts, such as this little tin figurine of a dog, or this specialized power plug. So much smaller designed objects that sometimes the handheld scanners just simply cannot pick up. And some of the other scanners aren't accurate enough to scan. So that's what this one right here is for. And it's the Shining3D Inspec that I've already mentioned. And we'll be going through the entire workflow to scan this little dog figurine. I'll have multiple videos on this one. Next up, we will have one with the multi-object scan. So you can use multiple small objects in each of these holes and scan them all at the same time, thereby saving time and effort. And we'll have a video on that. And then we'll have a different video on some of the automation processes that are possible with the scanner as well. So if you're interested in those videos, consider subscribing to the channel to get notified when I put those online. For now though, I'm going to focus on the dog, one of the very simple scans that we can do with this scanner. However, before we get to that, with a 3D scanner, one of the most important parts is calibrating them. And on this one, the calibration process is real easy. We just have a calibration plate that is usually stored in this nice little baggie to protect it from any sort of damage, because we don't want this to get scratched. So we've got this right here. And then on the screen, on the software, we have the big recalibrate button. And that's what I'm going to click now. You need to do this the very first time you get the scanner, every time you've moved it to a new location, if the lighting changes significantly, or if there's a temperature change. So for example, if I leave this scanner overnight in my car and then I take it to the office the next morning and want to scan with it, I'm going to have to do a calibration. Now for the calibration, you can see first you need to select the calibration file, and then you can start the actual calibration. This step one. In that drop-down menu, it is possible that if you just installed the software, you don't have that calibration file yet. And then there's a download button. And if I click that, it asks me for the number of the calibration board. And it's right there. And then you can enter this number into that field. So that's exactly what I'm going to do. And it's the 2020032500054. And this is necessary because each one of these calibration plates is actually very, very slightly different from one another. And this number guarantees that you get the optimal and most accurate calibration possible with your specific plate. So you click confirm, and then it'll download the calibration file for this specific calibration plate. If you don't have internet access on the computer where the software is installed, then write an email to the Shining3D metrology support and they will send you a file on, that you can download and then transfer to a specific location on your hard drive using a USB stick. That way you don't have to connect this computer to the internet if that is not possible in your location. Now that we've done that, we need to take the little riser block, the offset, whatever you want to call it, the gasket, I think is what they call it, and we're going to have to use that in between the calibration plate and the platform. Now you might be able to see that there's three half spheres out of metal sticking out from this platform, and they are there in order to align everything that we put on top. Most of these little additions have little indentations on the bottom to fit snugly onto these half spheres. Same deal with the riser, and the riser of course has more of these spheres on top, so then I can put something else on top of it. So I'm going to start by placing this riser, and it snaps right into place. And then my calibration plate, and that one as well snaps nicely into place. So now that I've got it right there, I can start the calibration just by clicking the button, Start Calibration. Now I'm going to have to wait. It'll take a couple of minutes, so I'm just going to stand here, stare at my scanner until the calibration process is done. See you in a few minutes. All right, so that's it. Calibration is done. It said success. Guess there's a small translation error there, but it was successful, and we're now ready to work. Now we can see our latest calibration date is today, March 9th. That's when I'm recording this at 14:26. So as you could see, the calibration process itself was real easy. I selected the calibration file from the drop-down menu and pressed start. Then I waited. You could have grabbed a coffee or something along those lines, and when you come back, the calibration process is ready. So I can now remove the calibration platform from the scanner again, place it back in its little black bag so nothing happens to it, prevent any damage, because we don't want any scratches. Normally I'd put it back into the cardboard box that the entire scanner came in, but that one is out of frame and I don't want to walk around right now. So I'm just going to keep it here on the desk. Now, I said I wanted to scan this little dog. And to do that, I'm just going to use the very simple plate edition with a little bit of Play-Doh on top. Clay? No, it's not the right word, but I can't come up with the correct word in English right now. Whatever Play-Doh is, the stuff kids play around with. So I can, stick my dog in there and it'll stay in place even when the plate rotates, even if it's upside down at some point. I'm going to click New Project, and then I can select the save path and I can name the project. I'm going to name it Dog Scan. Now I have multiple options. I can select the single or the multi-object mode. Multi-object mode, that's this one. It'll be in a future video. Stay tuned for that one. Then there are textures. This scanner cannot detect colors. So it will not be able to give you a textured scan in the sense of this part is area, this part is yellow, that area is green, that area is white. For example, if I scan this, it will not have orange and white. Instead, what it does is it scans a grayscale image. So you can see that there are different colors, but they won't be colored properly. Still, sometimes grayscale is all you need, and that is something that is possible. My dog, however, only has one color, so there's no point enabling that option. Then remove curved edges can yield better results on parts with sharp edges, for example, because sometimes the way the scanner looks on top, a sharp edge may appear as rounded, and then instead the scanner just cuts it off, thereby improving the overall scan quality. So I'm going to leave that on. And the inspection template, that is something for automated scanning and file saving. As I said, that'll also be the content of another video. Stay tuned for that one as well. So I'm not going to need it here. Keep that on null. Just going to press OK, and then we can actually start scanning. Going to place my little plate. Again, it snaps into place with the magnets and the little metal half spheres. This is the basic scan interface. At the bottom right, there's a button to start scanning. On the right-hand side, there are some tools that are as yet unavailable. And I'm just going to remove this real quick. On the left-hand side, this is a preview of what my camera sees. Below that, I can adjust the brightness, and to the right, I can adjust the height. That is something that I will have to start with. So I'm going to click Activate Height Adjustment. When I click that, the scanner will rotate the plate so that the camera looks on sideways onto my model. This way, I can adjust how the scanner actually looks at my model. And generally, you want your part to be centered on this screen. So I'm going to be able to move the slider down a bit, and the mirror that is inside the scanner will move, trying to position my part higher in this preview window. Now I'm still unhappy with this. This is still in the bottom third, even though I've already set it to 0, so I can't get any lower. So what do? This is where the riser comes into play once more. So I'm going to remove my little plate with the dog, and instead I'm going to start by placing the riser onto the plate, and then put my dog on top of that. And now you can see it's pretty nicely centered, but I'm going to move it very slightly. Let's make it the 13. And now you can see it's perfectly in the center. And then I can use this blue line. What is the blue line? Well, it is a cutting plane. That means anything below the blue line will not be picked up by the scanner. It'll just ignore everything below that. So now I placed it just below our dog. That's fine. We'll have some of the clay also scanned, but it'll just be fine. Now we need to do, we're done with the height adjustment. Now we need to do the brightness. And there's an automatic setting that you can use, and the scanner will try to find the optimal brightness. However, in my opinion, sometimes it just over-illuminates the part way too much. So this right here, I don't want it on 16. I'll probably go for an 11. see what it looks like. We're just having the first red spots on our model. Might go down another one. Let's see what the 10 looks like. Yes, that's better. 9. Let's keep it on a 9 and just see what happens with that. There's also a device adjustment where you can see the 2 cameras. You can have a projection test where you can make it project stripes, and then you can see whether the cameras and whether the projector are working properly, all of this stuff. But I'm not going to touch any of this for now, just leave it as it is. Then there's an option whether or not to capture markers. Now, markers on this scanner are not necessary to align the part, as they sometimes are, for example, with the handheld laser scanners. With the handheld laser scanners, markers are necessary on your part in order to allow the scanner to figure out where it is in the room. But on this scanner, these little markers are designed for increased accuracy. And they're not necessary on a geometry such as this one. Where they might be necessary is if you have very large surface, but very, very thin-walled models. For example, a jaw implant, you know, a plate that goes this entire way down to the jaw, and it'll be very thin, but it'll be this entire length. And if you wanted to scan something like that, you might want to use markers just to make it easier for the software to achieve the high accuracy that you expect. But for this model, we're not going to need any markers. We're going to be able to just scan like this. So I'm going to leave that setting off, and I'm just going to click Scan. Now, by default, the scan path has 10 locations, and you can see that on the bottom. It goes through the 10 locations, and it'll start scanning everything in those 10 areas. 6 out of 10, 7 out of 10, 8 out of 10, 9 out of 10, and these are a preset scan path. And we're just going to be able to let the scanner do that. Then we get a little info window about what the buttons mean. I'm going to click that away for now. And this is now our scan. We can have a look at it. We can see there's still some holes. I'm going to get to that in a second. But other than that, the basic surface of the dog already looks quite good. We still have some of the clay down below. This blue circle is my cutting plane, and I could move that up or down now. But if I moved it up, I would not only cut away the clay, but also the legs off of my dog. So I don't want that. I'm going to leave it nicely down below. On the left side, I can see all my scan frames. Those are the 10 steps that the scanner did. And I could select whether or not I want them viewed or not. I'm going to keep them all on. I'm going to lower the brightness for the next scan. Put it just, make it a 7. But what I want to talk about with the dog now is I want to get rid of this extra clay because, well, it's not supposed to be there. I don't want any information about that. So on the right side, I am going to select the free select tool, and now I can just click and drag in order to select the areas that I want to delete. I'm just going to select all of this. Okay. You can see it's marked red now. That means it's selected. And then I have some more over here. Try not to cut off too much of the dog's leg. Something like that. And then some more over here. Try and get an angle where it works nicely. You can also do this in multiple steps. So now I've selected everything I want to delete for now, and I can either use the trash can icon on the right side or the delete button on my keyboard. Now I want this right here to be gone as well. So something like that, yeah? So that's how you can delete all the clay that you don't want to be in your scan. Any unwanted parts, so to speak. But I should have done a different sequence of events first because I'm still having all of these holes. I actually want to add more information to my scan. The 10 points or the 10 scan locations that it had were evidently not good enough because I'm missing a lot of information there. I'm missing quite a lot of information down there. And if I want to mitigate that, I can orient my part in a way that I'm looking at where I'm missing data. And then there's a button on the right named Add Scan. And if I click it, the scanner will now rotate the plate to the exact view that I had and scan that one again. And now you can see everything that is green was just added. So I'm going to rotate it a little more. There's another blind spot back there. And you can see if I look too far below, then the button is grayed out. That is an angle where the scanner cannot reach it. If I go a little higher, this button will once again be available. So let's try and get a little more information on that area back there. Perfect, got that too. I'm gonna rotate it to the other side. There's still some area that I'm missing down below. Make it so the scanner can actually pick it up. Ah, it's too high on this end. Can still try like this. Just see what happens. Click the plus button. We'll try and scan this. There we go. That was also not too bad. Now I want something from underneath the tail here, but I can't go too far. Doesn't let me. Still not able to. There we go. Let's just see what this gives us. And now in my case, I just have this one dog, yeah? So it doesn't matter too much that I have to do this manually. But say I wanted to scan 50 of these dogs and then automate their comparison. Well, I wouldn't want to have to add all these individual images to my dog afterwards each time. So what I could do is I could now save this new scan path, including the first 10 scans that it did, in it, and then add all the ones I did manually now, and I could save these and call them, I don't know, the dog scan path, yeah? And then the next time I could select it from the drop-down menu, the dog scan path, and just use that from the get-go and scan all of these images in one go. Now I'm gonna delete some of these areas again because I picked it all back up. That's why I said my sequence of actions was actually a little off. I should have done the additional scans first before deleting anything, but no big deal. We'll just delete all of this again. Here we go. You can go away. You can go away. There's still some at the front. Right in between that. Don't want to delete any of my dog. And somewhere here. I'm gonna have to cut off a tiny bit of the leg. Like that. This looks pretty good, and we added some information on the tail at least. So I'm gonna click apply. That's it for now. And now I have three options. If I didn't like the scan at all and I wanted to start over, I could press rescan. It'll delete everything we just got, and it'll try and scan this model once more. I can also select flip scan, which basically means do another scan of the same model in a different orientation. That's what we're gonna use in a second. And then I have Datawrap, which is basically when I'm done and it'll mesh my model. But for now, as I said, I want another view on this. So I'm gonna take my dog and close up the clay a bit again so it's nice and solid. And then I'm gonna take my dog and stick it in with the head down in the clay. So this way, I can pick up the tail and the legs very nicely. So now I'm gonna press flip scan and just wait for the scanner to do its scanning thing again. And now you can see we have 15 steps. Why? Because I changed the scan path from default, which is the 10, to 15, which includes my manual ones. Of course, now it is in a different orientation, so who knows whether that was really necessary, but it's gonna do it anyway. So now we've gotten 15 more scans. And now the same process applies. Check, am I happy? Am I missing information anywhere yet down below the tail? But that is something that I already picked up in the first scan. Other than that, this doesn't look too bad. So it is time for me to remove my leftover clay. Cut it off there. Cut around the head. This time around, I don't need to be as careful because obviously I've already got the entire head in the first scan that I did. So I'm gonna rotate it around like this. Cut some more off here. That looks good to me. Press apply. And now I only have two options, rescan or alignment. Rescan if I don't like this one and I want to do it again, or alignment if I want to match it to my already existing half of the dog. Now the software is gonna try to do this automatically. Maybe that's good enough. We'll see. Sometimes it works very, very nicely, and sometimes somehow it really messes up. So on this one, looks perfect. You know, it figured out where the tail was, it figured out where the head was, it also matched all the legs. That's why it was important not to cut off too much in each one of the scans, because even though I scanned it a second time, it is important that there's already enough of the model to align it. Now this time around it worked, but what if it doesn't? Then at the bottom right, there's a manual alignment button, and I'm gonna click that and act as if it failed, just so we can do it once more. Now, I need to select 3 dots on each one of these models in order to give the software an idea of where to start. They don't need to be perfect, but for example, I'm gonna select this right here. There's a little bulge. I'm gonna click Control on my keyboard and then double click it with the mouse. So it selected that. Now I have to find that same bulge on my other scan. And I'd say it's this part right here. So I'm gonna click Control and then double mouse click. And now we can see there's a red dot. And then I'm gonna use this muscle right here, double click. What is that? That's this one, I'd say. Double click. And as I said, it doesn't need to be perfectly identical, but the important part is that it has multiple spots where it can try to align it. Let's do something on the other side now as a third one. They can all be on the same side. They can be somewhere else. I don't know, let's try and select this start of the tail, I guess. Just right there. And that should be approximately here. Come on. There we go. And now I've got 3 dots on each one of these scans, the one without the head, the one without the legs. Now I press alignment, and then the software will start aligning these 2 models based on the 3 points that I just selected. So I've helped it. Now I'm gonna click OK, and now it is done. This is my completed dog. Of course, it's quite possible that due to the model geometry that you have, there's still a hole in one of these sides. So you can just repeat the process. I could remove the dog from my clay and put it in there sideways and add another flip scan. So you don't need to flip it 180 degrees to add another orientation scan. It just means it is one additional one. But on this model right here, I am now satisfied. I've got my dog nice and complete. It looks good to me. So I'm gonna say Datawrap. I'm done. Now I can rename my save file. I can tell the software to scale my model in terms of file size. It kind of simplifies the model a little bit, but honestly, I generally keep it between 60 and 70%. I've never seen a significant loss of detail. You can have this anywhere between 100 to have the true scanned file or down to 10% to have a simplified model. As I said, I like to keep it between 60 and 70. I find that yields slightly smaller files, which is nice. Over time, you do accumulate quite a lot of scans. And at the same time, it keeps a high enough fidelity to the original part that you don't lose any detail. Then the Datawrap method, watertight or unwatertight. Watertight means all the holes in the model are closed. Unwatertight means it's a surface-only model and it will have holes in it. We're gonna start with that. Remove highlights. That can sometimes happen if your part is shiny or reflective, which this one was, and we could see it in some spots on the model. It means there's tiny little spikes on the outside due to reflections of the light. So I'm going to turn that on here in this specific case. Then if I have a thin wall part, I can check yes, I don't in this case, and I can let the software automatically close holes anywhere with a circumference of up to 500 millimeters or down to 0. That means the software will automatically check for holes in your part, and if their circumference is smaller than the value you set here, it will attempt to close them. Now I've set it to 0, so it will not be able to close any of them. I'm gonna press OK, and now the software calculates my finished data. So we can see it is now processing, and then I get my finished surface model. You can see it's quite a lot of holes because of the remove highlights. That was evidently a mistake. It thought way too much of my model is a highlight, and I'm gonna have to redo that to prevent it. But now that I'm here, I can show you a couple of the other options on the right side. Once again, I could select areas of my model and delete them. I can change the view via these automatic viewfinders, or I can try and fill holes. For example, I can rotate it and then select this hole. I want to calculate it closed, so I select it. Now it is green, and if I press OK, the software will calculate a filling. But as I said, I don't like this. There's way too many holes, so I'm gonna go back. I'm gonna delete this, and I'm gonna go back to the scan step. I'm gonna have to confirm, okay. And now I can redo this. I can say once again, or move the cutting plane away, Datawrap, unwatertight, don't remove my highlights, and press OK. So we're gonna wait, see what happens this time. That looks much better. This time around we have almost the entire tail, the entire face, and now you can see that this little tin model of the dog isn't actually as detailed as you would think from farther away, because the scanner is more accurate than the modeling method used here. So the face doesn't look very nice, and that's not the fault of the scanner, that's the fault of my origin model that I scanned. It's just not detailed enough. But we can very nicely see the overall fur surface and where the snout is and the general look of this figurine. And yeah, again, I could fill the holes. But this now is a surface model. What if I want a watertight one? Well, I click back to scan, okay. And now I once again click Datawrap and I select watertight and okay. And now I'm gonna wait. Okay, so this time it'll take a little bit longer in order to finish the calculation, because now it has to close all of the holes that are on my model. Watertight means there's no more holes in that part. So this right here is now my watertight model, and on the model list on the left-hand side, I can see it is now DocScan 1. So I'm gonna click the little eye to blend out the surface model. This now is my watertight one. Once again, I can change the view. I can delete something if I really want to, but mostly I am done here. This is my watertight model. Finished. I can click complete. Both of these models, both the surface model and the watertight one, will have automatically been written to the save location that I determined at the very start of this whole scanning process. I was able to determine a save location. And as soon as I get to this post-processing stage, as soon as I say data wrap, the software will automatically write the save file to that location with these models. So I can click complete, I am done, I can now start a new scan, a new project. But what if I want to go back and actually edit something I've done previously? Well, I can click on import project and then navigate using the browse button to whatever project I want to change. For example, right now I want to do something with the dog scan again. So I'm gonna be able to reopen that scan that I just had. Once again, I can go back to the scanning menu, and then I can add more flip scans. I can delete some areas and rescan them, whatever else needs doing. But for now, I'm just done. Everything I wanted was completed, so I go back to the post-processing, I click complete, and I am finished scanning my little dog. And that's all I had for this video, because the other video with the multi-object scan or the automation, that'll be in future videos. So thank you very much for watching up until here. If you do have any more questions or comments, please leave them below the video. I hope you enjoyed this. I hope you found this interesting. And if you did, consider subscribing to get notified whenever we do more videos about 3D scanning or 3D printing. So that's it. Thank you very much for watching, and I hope you have a wonderful, wonderful day. See you next time.